Okay, so thank you for having me. It's a real pleasure to be here. My name is Matthew Jordan. I'm the Asterisk project lead for Digium and an engineering manager at Digium. Before I jump into Asterisk 12 and PjSIP, I saw a number of AstriCon shirts in the room from Denver in a couple of years. How many people were at AstriCon this last year? Okay, a handful. Of those handful, how many people know what was done in the Asterisk project in Asterisk 12? A few, and James is sort of like, I forgot, it was AstriCon, you know. ARI. So for those of you who aren't aware, Asterisk 12 was a very different release for the Asterisk project. We had 3 major projects that went on simultaneously, one of which was to write a new SIP stack based on Kamailio's PjSIP. There were 2 other projects that were also almost of equal scope, or in some cases of the same scope. One of which was to completely redo the bridging core inside of Asterisk, including impacting all of the reporting mechanisms, all interfaces, we really ripped the guts out of the core of Asterisk. The other project was actually to introduce a whole new interface called ARI. I'm going to allude to those 2 things in this presentation. I'm going to focus today on the PjSIP one, but it's been a very exciting time in the Asterisk project, and I'll also talk a little bit about how we managed to actually do that size and scope of work. So the actual title of this in your schedule is Asterisk's PjSIP Channel Driver, a SIP Architecture for the Future. And I like that title, I came up with it. And then on the plane out here, I thought, you know, that might actually be giving the wrong impression that this doesn't exist yet. And it does exist. The architecture's there. The future is now. There are some features that may not be there yet. We're working on them. We're continuing to actually integrate them into Asterisk 12. So we have new features in every single point release of Asterisk. But the architecture is what we really wanted. It's what the Asterisk community worked hard on and decided on and has really been pushing forward in Asterisk 12. But why did we do that? Why write a new SIP stack? We have Chan SIP. It's been around for a long time. Why go through all the work of writing a new SIP channel driver, of writing a whole new SIP stack? So RFC 3261 was published in June 2002. Giving Mark Spencer a ridiculous amount of credit, he managed to get Chan SIP committed into Asterisk that same month. What's interesting, there's a couple things I like about this. That was revision 472 of the Asterisk project. We're up to revision 430 some odd thousand, I don't know, somewhere around there. So this was very early on in the Asterisk project. And this was actually for version 0.1.12. And I think Ule probably remembers that, and I certainly don't. I was certainly not involved in the Asterisk project at that point. But that's 12 years ago, and that's a lifetime. That's an infinite amount of time in the lifetime of a software project. So thinking about 12 years ago, there was no Facebook, Twitter, or even MySpace. The only social network we had was Friendster, which I find really funny because, you know, MySpace came and went in the amount of time that Chan SIP has been around. And so even the social networks that we kind of mock at this point didn't even exist at that. It was not even around. So Linux was different in 2002. Red Hat Enterprise Linux was just released, the first release of Red Hat Enterprise Linux. Fedora, as a project, didn't exist. Red Hat was actually changing its business model in that time frame. And think about how different that is today. We didn't really have smartphones. The BlackBerry 5810, the first GSM-enabled BlackBerry, came out on the market in 2002. This is technically before iPhone. So Asterisk was also very new. I actually dug into the Asterisk users mailing archive list to see what was being talked about in 2002, and I found a grand total of 2 emails. I have a feeling we lost something in the archive around that point in time, but I think it's funny that one of those 2 emails is unsubscribed. So we had a ways to go as a project at that point. All of this is sort of a bunch of funny little evidence to say that time has moved on, and Chan SIP's architecture was never designed for the current size of it and for all of the functionality that is actually implemented in it.
It was never designed for SIP.
Very true. It was based on X2.
We tried to fix that during 10 years.
Yes. You know, it is a testament to everybody who worked on it that it has existed for as long as it has, that it has serviced. I can't even do an engineering calculation on the number of calls that Chan SIP has serviced. And that's not for nothing. You know, every Asterisk installation that manages SIP calls uses Chan SIP. And that reliability, that that dedication by everybody who wrote that channel driver is not for nothing. So this was not an easy decision for the Asterisk project. It came about as a very long, slow, painful process where we finally decided that we couldn't keep extending it to make Asterisk do the kinds of SIP things we wanted it to do. But we also wanted to preserve the good things about ChanSIP. And the good thing about ChanSIP are things like it is highly interoperable. It does work with a lot of different SIP stacks. It has all sorts of strange workarounds put in there to work with strange providers and all sorts of things. So we really wanted to try to take the good from ChanSIP and yet also provide the architecture that we really wanted in the Asterisk project. And this is what we ended up with, a bunch of pretty blocks. At the bottom, we have PjSIP. PjSIP provides the transports. We do add some additional transports to PjSIP, but it provides a lot of the basic transports. Provides the transaction layer, provides the whole SIP stack that you would actually expect a SIP stack to provide. Where we start is at a few different points in the PjSIP stack. The first module in Asterisk that begins to interface with PjSIP is, not surprisingly, called REST PjSIP. It's not a channel driver, it's just a resource module. And this resource module provides the rest of the SIP stack in Asterisk a lot of useful APIs for interacting with various parts of PjSIP. It provides all of the threading mechanisms. It provides thread-safe queues, a thread pool. It provides mechanisms for message distribution through the rest of the stack. So a lot of very common, useful frameworks and APIs are built in this resource module. Once you get out of this resource module, and these green things are sort of managed by REST PjSIP, we then start to look at things like endpoint identification and authentication. Every single request that is processed by the SIP stack is identified with some endpoint. How we identify requests with an endpoint is actually provided by completely separate modules than REST PjSIP. The logic for performing that endpoint identification is completely pluggable. So if you wanted to change how you map a request to some sort of configurable thing inside Asterisk, you can do that. It's a couple hundred lines of C code. Authentication is pluggable. So as we were talking about today, the IETF is looking at things other than digest authentication. Currently, that's what we have as a module, is an authentication module that uses digest. But if we wanted to have an authentication module that did OAuth or some other mechanism, it's a pluggable architecture. We could write one. It plugs right in. There's no changing any of the rest of the code in the SIP stack. It just uses that method for authentication as opposed to something else. As we move up the SIP stack, we enter into something that we call supplements. And supplements are modules that can look at a request and modify the request as it flows up and down through the stack. It can modify responses, but they typically aren't the last thing that actually creates a response to a request. A good example of a supplement in this part of the stack is something that adds or consumes path headers off of a request. So it tries to put or modify the path headers that are going on in the actual thing and then says, okay, now it's ready to go, it goes out the door. But something else already recreated the response, it's just adding the headers to it. Once we get out of sort of this general sort of area of the stack, things tend to get shunted off into one of 4 different modules. And these different modules provide common frameworks for doing sort of particular types of operations. They're relatively self-explanatory. Messaging handles message requests, publish subscribe handles publish requests and subscribe requests and notify requests. Registrars, your registration requests. And finally, REST PjSIP session handles invite requests or anything having to do with media. And as things flow up, it'll flow up into SDP handlers and session supplements. So these are similar to these sort of general supplements, but they actually modify media streams. And then finally, at the very top, we have a very thin channel driver. And this channel driver only serves to act as a facade between the overall SIP stack and the Asterisk channel core. So while ChanSIP was roughly 34,000 lines of code, PjSIP, I believe, is maybe 2,500, 3,000. So it's just a small layer between the two. So what does this look like? So we're going to look at an inbound invite request as it goes up and goes through the stack. So PjSIP, I'm dropping out the transport layer here because I'm assuming we're just going to use a common transport. If we used WebSockets or something, you would have a Asterisk module that was the actual WebSocket transport, and then it would go back into the PjSIP stack at that point. We'll just assume we're using a standard transport. The first thing that happens when an invite request comes in is REST PjSIP picks it up, and a file in REST PjSIP called distributor says, okay, we have a new request. I don't know what to do with this. I'm going to stick it in a thread pool for processing. So unlike PjSIP, which was single-threaded and would block anytime any request blocked as it went out to a database or did anything else, ran a long-running DNS query, nothing ever blocks. There's a thread pool, and if a request comes in, we put it in the thread pool for processing. If another request comes in, we put it in another thread in the thread pool, and it just keeps on going. Hooray.
We have a lot of threads and Asterisk processing SIP, but the reading part is single thread.
I didn't hear that earlier. What was that?
You were a bit naughty here. We have a lot of processes and a lot of threads and Asterisk handling SIP calls, but the socket reading part is the only single thread part.
Absolutely.
Be fair.
Yeah, we haven't even gotten anywhere close to a PBX thread at this point. Well, that'll be the last thing we do. So once it's on a thread pool, it starts traversing up through the stack. And the first thing that PjSIP will do is it looks for an endpoint identifier. There's several endpoint identifiers already in Asterisk today, but again, people can write their own. So if there was a special way you wanted your Asterisk server to identify requests coming from a Kamailio instance, you could provide your own endpoint identifier. Say, I want to look at this thing on the request URI or something else. You could go ahead and do that. In general, one of the more common ways is we look at the user portion from the from header. Say, oh, that must be the endpoint that you want. There's also an anonymous endpoint identifier. So if you want anonymous calling, it says, okay, well, no other endpoint identifier serviced this request, so we'll tag it to this anonymous endpoint, and that anonymous endpoint is the generic thing that all anonymous calls will get associated with. We drop up into PjSIP NAT, and if you had NAT, this will try to figure out what to do with the NAT and apply NAT settings to the request and modify the addresses accordingly. If you don't have a NAT, which you may not, if you're like Ule, you have IPv6 addresses for everything, then you don't even need this module. You can just drop it out. So, this is a pluggable stack. If there's some piece of functionality you don't need in the stack, you can slim down the stack as much as you want to create a more efficient SIP stack for your installation. This is sort of a funny one. PjSIP session, which typically handles calls, actually inserts itself multiple times into the PjSIP stack. One of the places it does that is at the UA proxy layer, and it simply does it to see, hey, is this a re-invite? And if so, I'm going to tweak some media state things. In this case, because this is an inbound invite request that is just a straight up invite request, not a re-invite, it says, nope, it's not, I can't handle it, move on. So we end up going off into authentication. Authenticate the request. Normally, if we were going to challenge here, this would return back a 401 at this point, and then we would stop, and then we would wait for the invite request to come in with authentication credentials. But we'll assume we've got that, so we'll move on. We finally end up back in PjSIP session. We make a new session, so this starts to create RTP instances for each different media stream that's actually in the offer. We actually process the offer in another module called PjSIP SDP RTP. So if you want to add new extensions to the SDP, such as bundle support or some other WebRTC extensions, you don't have to go digging through the channel driver, PjSIP session. You can actually also add your own SDP handler. So there's actually multiple SDP handlers depending upon what media types you want to handle. We go off into PjSIP caller ID, pull out the caller ID, store that. And then finally, we end up in the actual channel driver. And the first time it goes in the channel driver, all it does is it makes an AST channel object. So up until this point, we've been pulling everything out and storing it in different places, but we still don't have a channel object. We finally now have a channel object. And hey, we go back into the stack. We end up in PjSIP T38, ew, fax. That's terrible, but we wrote it. We don't have anything to do with T38 fax. I'm just going to pretend like fax doesn't exist. The interesting thing here is we actually go back into the stack because the T38 processing in Asterisk requires an AST channel object. So it tells the channel driver, make an AST channel object, then I'm going to go handle the fax stuff, because if this is a fax gateway relay, I have to use the AST channel object to find out what's on the other side and do some other fun things. And finally, we end up back in PjSIP, and this is where it enters into the battle plan. And the call finally goes off. We start a PBX thread, as earlier pointed out. There are plenty of threads actually processing things, and we finally start the Asterisk PBX thread to go ahead and process the call. So that's walking through the stack. Configuration, very different in the PjSIP stack. This is a really funny name that Joshua Kolb, one of the Asterisk developers at Digium, came up with. I think he was fairly surprised that it worked, and so he called it Sorcery. It's a data abstraction layer. How many people are familiar with object relational mappers, such as Hibernate or Hibernate? Okay, cool. This is very similar to that, except that we're not really object-oriented, and it doesn't have to be a relational database. So it's for some values of O and R, it kind of looks like an object relational mapper. It is, however, a generic data abstraction layer that sits on top of real-time and static conf files and any other way you may want to provide configuration information into the PjSIP stack. Supports basic CRUD operations, create, retrieve, update, delete. But what it really provides us that's really cool is it gives everything that the stack is using that came from configuration data a well-defined lifetime. So if you unload a module or reload something or generally perturb the system, if you have a call in flight, it keeps going with the same information that it's always had. And it will continue to work with the same information that it always had. And then the next time it does a call for whatever you change, they'll pick up the configuration changes, and so you have a very stable, predictable model of how the system will behave in the presence of configuration changes. Another nice thing about that is that if you go change your configuration data in a database, you don't necessarily have to reload your Asterisk systems. It'll just pick up the database changes the next time a call needs to go actually use that information. One of the results of this, however, is that the configuration for the PjSIP stack is broken up a little bit more into smaller objects. That does have some advantages, it has some disadvantages, but it does have some advantages. One of those is that you can take advantage of more complex database schemas and more useful database schemas. You don't have to have everything smashed into one giant table. You can take advantage of templating in the static conf files. You can also specifically determine the storage location of each object. So I could have my endpoint configuration defined in a database. I may have my transports defined locally in a static conf file. I may have my contacts in the Asterisk database locally on each machine. I may say, no, I'm actually integrating with Kamailio, and it's the registrar, so I want my contact information to be read from the database. You can pick and choose between all of the various pieces and determine where you want that in your system. This is sort of the general objects. There's a bunch of others, but these are the most important ones. Endpoint really is the most important concept. It's the thing that everything gets tied back into. Endpoint has a transport. It has an AOR, which simply defines the number of contacts that it can have, as well as their type. An endpoint has authentication, and we also have outbound registrations and some other things. There's some other objects. It's probably easier to look at an example. This is what it would look like in a static conf file. So if I'm defining Alice, I say Alice is an endpoint. When Alice has a call, we want her to go into the internal context. We'll allow G722 and ALA because we're in Europe. We'll have authentication. Her authentication is provided by Alice Auth, and her AORs are provided by Alice AORs. And then you have specific configuration sections for those two things as well. So, Asterisk and Kamailio. It's like currywurst and beer. They just go together. So, okay. This is sort of a bad diagram of a very standard setup. We have redundant Kamailio instances. We have Alice and Bob and some public-facing connection coming in across our switch. We've got a private network in the background with a database that Kamailio and Asterisk are getting all of their information from. And Asterisk is really being used as some media servers. So I have an Asterisk instance that's doing some IVRs, an Asterisk instance that's doing call queues, and an Asterisk instance that is doing my voicemail. The configuration of this is very similar to what you would find out on the internet today. We tried very hard to limit the changes, the public-facing changes in Asterisk, so that it was possible for people to move from older installations of Asterisk and still be able to go to Asterisk 12. There are a few different things. Because PjSIP uses Sorcery for its mapping of its in-memory objects to its persistent storage, you do have to tell it for each object that you want where to go find it. So the endpoint object, for example, we say it's going to be in a real-time backend, and it's going to be in table PS endpoints. And the AOR information is going to be in a real-time backend as well. It's going to be in PS endpoints. And I could have said that that's in an Asterisk database, but again, because I'm integrating with Kamailio, Kamailio would probably be acting as my registrar, so I wanted to tell it to go get its contact information from the database. From a real-time perspective, the configuration looks very similar from what you would see in an older Asterisk installation today. You just simply map the table names to how you go get the connection. I would say these are some ODBC connections going to the Asterisk database. But what's nice, because I know I want Kamailio to do a couple different things for me, I can just simply unload parts of the stack that I don't need to use. So I would unload my authentication. I don't need it. I'll let Kamailio handle all of the authentication. That slims down the amount of processing that Asterisk has to do when an invite request comes in. It won't even attempt to authenticate anything ever. Removes the code to do so. We can unload as well the registrar. We're going to have Kamailio be the registrar. So that takes a whole lot of processing out. And if a register request somehow managed to find its way into Asterisk, and I don't know how, but let's say it did, Asterisk would simply say, I don't even know what this is. I don't know what this strange register request is that managed to get to me. This is very standard. This is sort of what we would view as things today. And I want to talk a little bit about what's next on the Asterisk project's horizon of things that we would like to go do. This has been something that's being talked about right now on the dev list between Ule and Paul Belanger and me every now and again. But it's certainly been something that's sitting in the back of our head as well, that one of the things that Asterisk could improve on is its ability to distribute presence information to Kamailio, to things that are subscribed to useful information. So today, if you wanted to get the MWI state, Kamailio would have to forward the subscription over to the Asterisk voicemail server and say, yay, verily, I'm going to subscribe to mailbox 7000. Same thing with present state. If for whatever reason my Bob phone wanted to know when somebody entered into an IVR, for whatever reason, maybe they want to know that somebody's actually trying to navigate through 8,000 menus, Kamailio would have to forward the subscriptions over in order for Asterisk to actually reliably publish the notify requests to Kamailio, which Kamailio would then have to forward over to the various things that subscribe. And that's not really ideal. Ideally, we would want Kamailio to be the subscription servers. We would like all of the subscription stuff to live there, and then the Asterisk instances, when things change, would just publish the state to Kamailio, and Kamailio could be responsible for distributing the notify request to everybody else better at the job. So, yeah, something like that. Somebody leaves a voicemail, and rather than sending a notify request, we send a publish to Kamailio that says, hey, the state of this event package changed, and Kamailio can choose to bundle that up in a resource list or something else and push it off to Alice or whoever else it wants to go to. So that's interesting work. That's something that's on the horizon I think we're looking at and talking about, and hopefully we'll make some good traction on that in the next couple of months. One of the things that's also in Asterisk today that we're currently working on and expanding on and enhancing is the idea of Asterisk just as a generic engine of communications, just as something that has very little business logic baked into it, but provides all of the fundamental concepts to people so that they can build whatever kinds of applications they want and treat it just as an expandable set of nodes of new communication. So what happens, for example, if we need more voicemail servers? Well, you could use Puppet and change the configuration of some of your servers and turn them into voicemail servers. That's completely possible, but it can be a little difficult at times. In general, we find it's not so easy always to just simply take an existing Asterisk server, change out its configuration, load it up with something else, and have it be very seamless. And the major constraining point of this is really the dial plan, because that's where all the logic gets baked in. One alternative that's in Asterisk 12 today is a new interface called ARI, the Asterisk RESTful interface. You'd think we would be more original with our naming of interfaces, but we're not. It's AMI, AGI, ARI. We have a good thing going with the three-letter acronyms, so we went with that again. ARI lets you treat Asterisk simply as an application engine. It gives you the fundamental building blocks in Asterisk that we would use if we were writing a C dial plan application, and exposes them through a RESTful interface and through some WebSockets so that you get notifications about that. That lets you push all the dial plan logic out of the Asterisk instances to some other server. So instead of having a dedicated Asterisk voicemail server, a dedicated Asterisk queue server, a dedicated Asterisk IVR server, I just have Asterisk instances. And I can make them do whatever I want. And I can load balance between them based on the CPU load or based on whatever else, other metrics I want. And then my application logic server, or wherever that application logic decides to live, can then control the calls remotely, or even on the same system, but probably remotely, through ARI. And that lets you really easily scale Asterisk out. If you need more compute power, you just use OpenStack, spin up the VM, throw another Asterisk instance on it, connect back to ARI, and you just keep on expanding. So, what have we been up to in the Asterisk project over the past year and a half? You know, when you guys are debating testing, I can't, and Alex has a good point, there are some things that aren't testable, but I cannot stress enough the value of the amount of testing that we've done in the Asterisk project over the past year and a half. There are 2.1 times more tests that test Asterisk trunk than there was even Asterisk 11. We're up to 433 functional tests that get run nightly. That includes everything from very simple SIP scenarios to creating chains of 150 local channels and then collapsing them all down to make sure that optimization works properly. That includes unit tests that actually exercise out the thread pool and the lower level sort of communication primitives inside Asterisk. And quite frankly, it's because of all that testing effort that we were able to go make these core changes and have an assurance that what we're able to release works. That it works on a lot of people's systems and it doesn't just work on our development machine. We're spending a lot of time in the Asterisk project as the community as a whole to continue to push the testing. We have a lot more things we'd like to test. We're going to continue to add more tests to make sure that when we add new features and capabilities, when we enhance and extend the PjSIP stack, that it works. So yeah, we're highly desired to enhance the publish subscribe support in PjSIP. I would expect that hopefully within the next couple months we'll start getting some real traction on that. And ARI, this is the other major focus of our development, is to really enable application logic outside of Asterisk. This was the other talk I thought about giving. Instead, I think I'm going to do a dangerous demo of that. We'll see what happens with that. And I have something mocked up a little bit that I threw together last night. And I'd love to show it outside, maybe during the beer hour. You guys can find me at the Digium table. I'll show you what it looks like. But it's very fun. Thank you.
Matt, questions? Okay, too many. So Ole first, and we have second, and then.
Well, Matt, I can't stress how important Asterisk 12 is for the Asterisk community. Some of the changes are changes we discussed from year to year. I think this goes back 6 years ago. So you've done a really, really great job with Asterisk 12, and I thank you for it. I look forward to the new SIP stack as well, and actually starting to work with it based on customer needs. Come on, Matt, more customers.
Tell me what you need, like.
Customers, money. But anyway, what I wanted to say is that I want all of you in this room to help Matt and us in the Asterisk project to make this really, really work well with Kamailio. There are things that is not there. There are things we can change. We got the path header support, which is really important for us. But there are a lot of other things. So continue to work together with Asterisk project. Now is the right time to feed information in to the new SIP channel on what we need that build large and scalable SIP networks, not just small Office PBXs. So please engage with Matt. Use him while he's here. He's a bit confused about time zones, but provide him with beer and you can talk SIP channel driver forever.
You probably won't get me to shut up then.
Okay, Emil.
Hey Matt, thanks for the presentation. I like an Asterisk user mostly, I'm quite excited about Asterisk 12. I had a couple of questions. So the first one is there any ICE work planned as part of the PjSIP integration?
ResRTP Asterisk does support ICE. We had a large number of bugs that sort of came to light over the past couple months. We just fixed it. What was that?
Trickle ice.
Oh, trickle ice. I'm sorry.
You're talking with the email.
I know.
I actually said ice, but trickle ice is also, of interest.
Trickle ice is not as much on the radar.
And just ice, regular ice.
So regular ice is in there.
Okay. And it's going to work with PjSIP.
All right.
Okay, my second question.
Let me know if it doesn't.
My second question was going to be, and I'm not sure if this is really specific to the PjSIP part of Asterisk 12, but how easy would it be, and is that really installed for Asterisk to, pick up calls and then pass the media to an external media component?
I would say it's definitely in scope. Ease of it would be interesting. I'd have to think about, there's actually, the part that actually is mostly responsible that is actually not the PjSIP stack, it's really the bridging core.
Right.
And the bridging core, and that's something I didn't have on here at all, is also pluggable now. So you can take mixing technologies and plug them into a bridge, and it can choose how it wants to direct the media. So if you wanted, you could plug in like for example, the Jitsi video bridge. you could actually plug in.
Did you read my mind?
I know, it's crazy, right? You could plug in a very thin C wrapper there that then told the media streams to go someplace else, and then just simply watch the signaling to see when the channels die, and let something else do all the media mixing and then send the media back, and just assume that the media is going where it needs to go. It'd be a very interesting project. There'll probably be a few hiccups in there, but it's definitely technically possible.
Okay, thank you.
Hi Matt. I heard some, well, channel agent and queue support in Asterisk 12 has been modified. So can you tell us the details, please?
So I wouldn't say chain agent was modified so much as deleted. Sorry. But what we did instead, so app queue is app queue. App queue pretty much remained the same, other than certain things inside app queue, such as some of the transfer notifications to update. The queue log had to be updated for the new bridging course. So there's mostly just small things that happen in app queue. Again, ARI would be our goal to eventually let you kill app queue yourself, but that's a whole other discussion. Instead of Chan Agent, which had some serious design problems that just were very difficult to extend, particularly with some of the new bridging work, we instead opted to let you build out the exact same thing using a sequence of dial plan applications. So you can create an agent pool. And in an agent pool, you can put any number of agents who are always logged in. They sit in a holding bridge and they're entertained. And then you can use another dial plan application called agent request to request any agent out of the pool, and then it grabs that channel out of the pool and bridges them in a new bridge. So it's the same use case of Chan Agent, where your queue agents are always logged in. It's just a different mechanism to reach that use case.
Thank you. That's not what my developer told me. Thank you.
Yep.
I was using Asterisk 12 just recently, and I saw the endpoint and the AORs as something very interesting. I was just trying to play with it, and then have several static AORs, and then I was thinking that it would randomly round robin between them. If one of them doesn't qualify, so it will disable it. You just use the first one. So
there's two ways to do it. By default, it uses the first one, or from the dial plan, you have two options. You can either specify the contact that you want to use from the dial plan, and then it'll use whichever one you want, or you can use the PjSIP dial contacts function, which then dials all of them simultaneously. Now, as far as logic that you just described, that would be really cool, and it would be doable. It's actually completely doable. It would be probably not a very large patch, but it would probably have to be done in the Chan PjSIP to do it. Because when you actually make a dial request in Chan PjSIP, you have all of the information. You have the contacts. You can choose which ones you want to go dial at that point. It's just up to the dial string to specify the right information for it to interpret it. Ule.
We can steal a concept from Shandadi where we have dial groups, and we have dial groups in SIP, so we already have the concept in Asterisk.
And Ule's right. That's actually probably the right way to do that, is to use as a dial group concept.
Quick question. In your distributed presence diagram, are you envisioning that the presence user agent in Kamailio would be subscribing to all the state on the Asterisk servers, or that the Asterisk servers would publish stuff up to Kamailio just kind of gratuitously?
Depends on what you want. Yes to both, depending upon what you want. I would say, as one option, you could certainly say which event packages you would publish to a Kamailio server, or you could go the other way and have Kamailio actually subscribe. I would figure you would probably want publish. And particularly if you had RLS implemented on Asterisk, you could then aggregate things together in a single publish or something along those lines. Well, not a single publish, that would be a single notify, but yeah.